In SolidWORKS, you can define equation-driven curves. It's done with either explicit equations or parametric equations. While in sketch editing mode, select Equation-Driven from the Spline drop-down menu. Leave Explicit option selected, and in front of YX, type SQRT X in parentheses. For X1, enter 0, and for X2, enter 2. The lock buttons in front of the X lock its value. Click OK when you're done with the parameters. This is the square X curve. Although it's not fully defined, you cannot change its size because we selected the lock option. Although you can change its position, make it fully defined like so. Now let's try another curve. Create a plane 5 mm away from the first plane and start a sketch on it. This time we use the log x equation. Notice that the distance between the origin and x1 is 1 mm, which is what we use for the curve. This distance is editable, but it doesn't change the x1 used to define the curve. The curve is drawn with its x1 set to 1 mm. The dimension in the sketch is used to position the curve, not to define it. In other words, it doesn't change the size of the curve. Try other equations. For example, x to the power of 3. Then give the x1 parameter negative values and see the result. In SolidWORKS, you can define equation-driven curves. It's done with either explicit equations or parametric equations. Let's go ahead and define the Involute Curve that was used in gear design. For xt, enter this equation. For yt, enter this one. The number 10 is the radius of the Involute Curve, and the t is the angle in radian. For t1, enter 0, and for t2, enter 2 pi and click OK. Remember that the t was in radians. The counterclockwise spiral is made with positive values of t, and the clockwise spiral is made with the negative values of t. If you measure this distance, you'll get the radius we entered in the involute equation. Changing this will not change the radius in curve definition. So, if I change this dimension to 20, then go to curve definition, the radius is still 10 for the curve. 20 mm is the position of the curve from the origin. You can use the name of the dimension in brackets, so SolidWORKS uses this value instead of the number 10. Each dimension in SolidWORKS has a name. If you hover your mouse over the dimension, you get a tooltip that shows it. D1 at Sketch 1 is the name of this dimension. At Sketch 1 means this dimension is in Sketch 1, just like email addresses. The @ sign defines the domain. If you ever decided to use the name of a dimension in an equation, you need to enter its full name in quotation marks. D1 at Sketch 1 would be the text to replace the number 10 with. Let me go ahead and show you how it works. As you can see, when I change the dimension, the curve responds to it. This is a very useful tool to design gears with involute teeth.